Alright, good morning guys. So today we are going to be jumping into a new section, the first section of chapter 4. And let's kind of recall what we've been looking at for the past few days. So lately we've been looking at how to graph equations in slope-intercept form and graph equations in standard form. So in those sections we were given the equation and then we were just figuring out how to graph them. In this section, we're actually going to be figuring out how to put those equations together and writing those linear equations in slope-intercept form. Alright, so let's go ahead and jump into this section. So first, to write equations in slope-intercept form, we need to use the slope-intercept form equation. So we've seen this plenty of times at this point. So y equals mx plus b. We know that m represents how the line moves, or what we call the slope. Okay. Now I know you guys know this, but for your first point in the chat for participation, what does the b represent? Okay, so m represents slope. What does the b represent? And we should have said that the b represents the y-intercept, or where our line begins. All right. So now that we know the slope-intercept form and we know the different parts to it, there's going to be there's about 3 ways for us to write these linear equations and put them together. So the first way is very straightforward. If you know the slope and the y-intercept, all we're going to do is just substitute them into the equation. So for example, write an equation of the line with a slope of -2 and a y-intercept of 5. So we know this slope is always going to come and replace my m right before the x. So my slope of -2, I can go ahead and substitute a -2 right here, where my m would go. And a y-intercept of 5, I'm going to go ahead and replace that b with my known y-intercept, which is 5. And just like that, I have my linear equation written in slope-intercept form. So now let's go ahead and try another example. So now we are going to write the equation of the line with a slope of 1/2 and a y-intercept of -4. So I always like to write down the linear equation in slope-intercept form in like a general sense. And then I can start plugging in those numbers and those values for my slope and y-intercept. Okay. So I know that y equals, my problem tells me I have a slope of 1/2. So where my m would be, I'm going to go ahead and substitute a 1/2. Okay. And then the rest of the problem tells me that I have a y-intercept of -4. So I'm going to go ahead and substitute a -4 for my b. Now this looks a little funny because it says y equals 1/2 x plus a -4. This plus a negative is really just the same thing as 1/2 x minus 4. So this is that linear equation that we put together once we were told the slope and the y-intercept, and all we did was substitute it into our general equation. Okay, so that is the first way of writing linear equations in slope-intercept form. Perfect. Let's go ahead and look at the second way, and that's going to be in an instance where we're given a graph. So looking at this right here, if you were shown this graph, which of the following equations do you think was used to draw the graph, and why? So we're given 4 options, and one of these options accurately describes this graph right here. We have to figure out which one it is. And what I like to do first to figure out or to eliminate options is to figure out what my y-intercept is. So for your second chat question is, what is the y-intercept? Okay. Again, that is where the line hits or meets this y-axis right here. So notice that this line meets the y-axis at the point 0, 3. So at a point where the x value is 0 and the y value is 3, what then is our y-intercept? Exactly, our line hits the y-axis at 3, so we can automatically eliminate these options C and D because it doesn't have that correct y-intercept. Okay. So now we have these two options left. Y equals negative 2/5 x plus 3, and y equals negative 5/2 x plus 3. Now I need to figure out the slope. I have my y-intercept, which is 3. I now need to figure out my slope. So I'm going to go ahead and look at this line right here. And I'm going to notice that from this point here, I'm going to go down 2 spaces. Right? I'm going to move down 2 spaces, giving me a negative 2 because I'm moving in the downward direction. And then I'm going to go ahead and move 5 spaces to the right, giving me a positive 5. So my rise is negative 2 and my run is positive 5. So your next question is the slope going to be the rise over run or run over rise? So when I use these two numbers to find my slope, will I put the rise over the run, so negative 2 over 5, or will it be the run over the rise, meaning the 5 over the negative 2? So perfect. If we did not already, go ahead and drop that slope is the rise over run. So it is the change in the y values over the change in the x values. So it will be negative 2 over 5. So A will be the accurate equation to describe this graph right here. So we used this graph to find our y-intercept and to find our slope, to then create this equation here. Pause if you need to go over any of these sections or rewatch any of the sections so far so that you understand the first 2 ways of how to write linear equations in slope-intercept form. But first, let's go ahead and get some practice with that second method, okay? So this says here, if you know, sorry, let me see if you can see all of it. Okay. If you know the 2 points on a line and one of them crosses the y-axis, use the y-intercept and use the 2 points to find the slope. So here it's telling us the 2 points are 4, 2. So we went 4 spaces to the right and up 2. So this point right here is 4, 2. And 0, negative 5. So 0 spaces to the left or right and 5 spaces down. Okay. So notice we can ask ourselves, where is this line hitting my x-axis? Whenever we have a point where the x value is 0, this point right here is actually going to tell us our y-intercept. So when our line hits our y-axis at 0, -5, the y-intercept then is -5. Okay. So I can say the y-intercept is -5 because that is where my line hits the y-axis. All right. And then we can go ahead and find the slope using those 2 points, using this little formula right here. So this formula says y2 minus y1 over x2 minus x1. And what those y2 and x2 are referring to is, say this is our first point here, we can call this x1, y1, and x2, y2. And all that means is this is the x value of our first point, the y value of our first point, and then the x and y value of our second point. Okay? So now I'm just going to go ahead and substitute those values. So y2 we said is -5 minus y1, which is 2, and then x2 is 0, and x1 is a 4. And then I will go ahead and solve. So -5 minus 2 is -7, and 0 minus 4 is -4. Keep in mind, a negative divided by a negative will result in a positive. So our slope is positive 7/4, or 7/4. And notice, just like that first method, guys, we now know our y-intercept, and now we know our slope. So all we need to do now is plug in those values into the equation. So remember that this is our m, this is our b. M is our slope, which is 7/4. And b is our y-intercept, which we said is -5. Again, this plus a -5 is really the same thing as y equals 7/4 x minus 5. All right, let's try that one more time. That is a lot of different pieces with the second method that we have to figure out. So let's go ahead and try one more. So say we have on this graph, we have 2 points here, one labeled 1, the other labeled 2. So your next question to start off this next example is, what is the ordered pair of the coordinate point labeled 1? So what is the coordinate pair of this point right here? So I'm looking for your answer to be in this form. Something, comma, something with the parentheses. I'll give you guys a second. So notice we did not move right or left any spaces. So my x value is a 0, and we moved down 2 spaces. So my y value is a -2. And then for my second point here, I have a 3, 3. And I'm going to go ahead and label these again, x1, y1, and x2, y2. So just like this example up here, I'm going to go ahead and follow the same steps by finding the y-intercept. And similar to this example up here, when we are given a point where the x value is 0, that y value in the ordered pair actually tells us what the y-intercept is, or where the line hits the y-axis. So we have a 0 as an x value, and our y value is -2, telling us that the y-intercept is actually -2. Okay? So now we know our y-intercept. We can go ahead and find the slope. And when we have 2 points, when we're given 2 points, the best way to find the slope is with this formula here, y2 minus y1 over x2 minus x1. And I am just going to plug in those values. So we said x2 is 3 minus y1, which is a -2. x2 is also a 3, and x1 is a 0. And then I will just solve. So -3 minus a -2 is the same thing as 3 plus 2, which is a 5. And 3 minus 0 is 3. So now we can say the slope is 5/3. And again, we have all of the parts to our equation that we can now just plug in. So we know for M, our slope is 5/3. And for B, our slope is our y-intercept is -2. So this is now the final linear equation of this line written in slope-intercept form. Okay. Pause at any point if you need to understand the 3 different steps that we took to write an equation in slope-intercept form when we're given a graph. Awesome. And last but not least, we have our third way of writing a linear equation in slope-intercept form. So a graph of a linear function is a line, obviously. We've learned that when we learned about what a linear function was. And you can use slope-intercept form to write a linear function. So write an equation for the linear function f with the values f of 0 equals 5 and f of 4 equals 17. So this notation here looks very familiar. This is what we call function notation, right? So this is telling us that when the input is 0, or when the x value is 0, we are going to get an output of 5, or a y value of 5. And similarly, when the x value or the input is 4, we are going to get an output or a y value of 17. Okay, and that's how we can come to this conclusion right here, where we can write f of 0 equals 5 as an ordered pair 0, 5. And we can write f of 4 equals 17 as an ordered pair 4, 17. Okay. So I now have 2 points, like I've had in the last couple of examples. I have my first point 0, 5, so I'm going to go ahead and label that x1, y1. And I have my second point 4, 17, so I'll go ahead and label that x2, y2. And then it's the same steps that we've kind of been repeating. We now need to find the slope. And again, we're going to use this formula here, y2 minus y1 over x2 minus x1. Okay. So I will go ahead and substitute in my values. So y2 is 17 minus y1, which is 5. And then x2 is 4 minus x1, which is 0. Okay. At this point, your next question is, what is the slope? So we've now plugged in our values. Go ahead and take a second to calculate it, and then let me know what you get in the chat for the slope. So 17 minus 5 is 12. 4 minus 0 is 4. This can be simplified so that our slope is 3, because 12 divided by 4 is 3. Perfect. Your last chat participation question is, what is the y-intercept? Recall we are given this point right here of 0, 5. Our x value is a 0, meaning this y value is telling us what the y-intercept is, which is 5. So now we're going to write the equation using a slope of 3 and a y-intercept of 5. And I can simply plug those in to the equation.